Good morning. Okay, I got a lot of material to get through. Last time I presented it, it took 3 hours, so I don't think we have 3 hours. It's a pleasure to be here this morning to present to you guys, and thank you for joining me this morning. Quick introduction. I work for GoGo. We're one of the world's leading Wi-Fi providers for airline industry. We have about 3,000 commercial planes. So for all of you who sit in an airplane bored out of your minds, the internet is coming. It's also pretty interesting. We do the connected IoT. Imagine IoT devices. When our IoT device is a $300 million plane. It's pretty exciting. Why am I here in Belgrade? We've got a great new team. We're working with InterVenture, and we've got a new office, and some of the team members are here today. I've actually had a lot of history in Serbia with development teams here since around 2000. So, anyway, what is this all about? 30,000-foot view, or I guess 10,000 meters. I joined GoGo from Netflix. I spent 4 years at Netflix doing cloud services, and we're taking what we learned at Netflix and we're applying it to GoGo. When I arrived, we had manual deployments in a data center. Silos between operations and development and quality. Deployments typically were measured in weeks, sometimes months. You could deploy in days, but that would be a chaotic event. It was a classic tightly coupled code base. 18 months later, we're still far from done, but some exciting things have happened. Operations have been absorbed into the organization, and we've built an amazing DevOps organization. We've rolled out automated deployments using Netflix Spinnaker. We've open sourced our first set of code, Formask, which is a templating tool to work with Netflix Spinnaker. We have the you build it, you deploy it, you own it mentality. Tens of thousands, actually 200,000 plus metrics are in the system. Developers have metrics is driven. We've got dashboards everywhere. Developers really understand how their code works in production. Quality engineering has been formed from quality assurance, and I'll talk about that later. And we're using a ton of open source tools, and I hope in these 45 minutes I'm going to be able to give you some insight into the tools we're using and how much amazing open source code is out there that you should be aware of and hopefully using. Some trends. I mean, moving 150 developers from a traditional software development model to a new model is very difficult. But we've got about 30% of our system now in the cloud. Our first airline partners are now moving into the new system. We're doing the classic roaming riding. I don't see any presentations, but we're literally building a new system in parallel with the old system and slowly transitioning everything over. We're already moving towards a 5 times cadence improvement. So code is going into production 5 times faster than it was a year ago. And yet at the very same time, we actually have a 26% reduction in problems. So sometimes people tell you can't move faster without introducing risk. We seem to be moving faster and reducing risk. Anyway, how do you do this? It started for us with DevOps. We really want developers to be able to iterate faster. It's not about making people work harder. It's just about removing impedance. It's about removing everything that gets in your way to be a successful developer. So we take a lot of silos in the organization and we break them down. So hopefully you don't have this, but many companies do have this. And to get software out the door, you have to go through these crazy procedures. Our goal with DevOps is to remove that. We want to go from this to something more like this, where a developer is in control. The developer has the ability to do all these things through automated tooling. You know, if you're visual, then you may think about this. I mean, sometimes when we were doing deployments, it was more of a panic. It's like, oh my God, I'm really scared. I don't want to deploy the code. And now we're trying to do this. The machine does it so effectively that everything just happens automatically. So we've gone from a world with many iterations to a world where, as a developer, you simply develop, deploy, test, and monitor. And if you break something, you fix it fast. Or with Spinnaker, we have instant rollbacks too. So Netflix Spinnaker is a really great tool. If anyone's interested in learning more, we've got some guys here who know a lot about it. But we've been using it to build our pipelines. It enables you to do the complete continuous deployment, and you can do a custom pipeline per product or per server. It's got a great UI. You can see some of the custom pipeline there. We use it extensively. And you may be saying, this wasn't a talk about DevOps, but a colleague of mine will be presenting tomorrow a complete breakdown into what we've been finding with DevOps. And I'm going to switch now more to the open source tooling that we're using. But I would recommend, if you have a chance, to come to see this, because there'll be some great information. So microservices, there's a lot of buzzwords out there. Microservices is one of them. IoT is another one. DevOps is another one. Well, they're not all separate entities. They actually all combine into one. The traditional Java model, or a lot of software projects, we've all seen it, start off with good intentions, and then they end up in this monolithic model. It's like having a big balloon. You squeeze the balloon here, and something breaks over here. Our goal is to untangle that and turn it into microservices. And I'd like to think of microservices as taking that big, long balloon and making lots of little balloons. And if you squeeze one of the little balloons, it has no effect on the rest of the system. The issue with these types of systems is you end up with massive pushes with a lot of risk and a lot of side effects. So we've been moving towards microservices with DevOps. You want to make the code easy. You want to make it self-contained. You want to have isolation of persistence. You don't want to have one giant database that everyone uses. You need lots of separate databases. Each team, each vertical should own the system end-to-end and build their microservices independently. So basically decouple your code. So how do you do that? There's a lot of people who've done a lot of presentations on that. I'm sure there'll be more or some here this week. And I'm not going to go too much into detail. But what I'm going to focus on is some of the frameworks and tooling that we've experimented with and we've found. There's a lot of cool code out there. The world's kind of moving, especially in the Java world, embedded Jetty, embedded containers. I'm going to go through a few things that we've looked at and we've been evaluating, some of the best in class that I think of. So Dropwood is one of them. It's actually a version 1 now, finally, after all these years. It's very opinionated Java. They wire up what they believe is the best frameworks, components. It's very well maintained. Easy to use, and it could be a way to get out of Spring and things like that. Netflix has Carry-On. This is another framework. It's got some great features and tooling. It has a lot of Netflix DNA built in. Netflix is moving away from this and moving more to a dependency injection model where you kind of wire up your own framework. And personally, I like to wire things up myself. But getting out of the gate and then having a large team, sometimes some of these frameworks are a little bit more easy to use. Another one that we've been using a lot lately is Spring Boot. We inherited a lot of code that was using legacy Spring. Migrating to Spring Boot has given us the ability to kind of get rid of some of the old Spring methodologies and move to more of a dependency injection model with this container. And there's a really nice project that we've been using, which is Spring Cloud Netflix. It takes Spring Boot and it wraps a lot of the Netflix DNA into it. I'm not going to go through all these details. There's also Spring Boot Admin. It's a great console. Again, you can plug this into your system. It's really not a lot of work, but it gives you extensive visualization of your code. You can go in and see any of your servers. You can change the logging levels. You can get thread dumps. It's a really nice feature. And if you're in a corporation, you can wire it up with single sign-on, so you can have corporate security. So this is another great tool we've been using. Two more that really should get attention. Reactive is coming. And Vertex and Play are two areas that we're currently investigating because we're getting everyone to Spring Boot, and then we want to know what's the next thing going to be. So that's it. I've finished. You pick a framework, Spring Boot, write code, you're done. I think a lot of us in software development can sympathize with this. We always have these good intentions, and then we go through, start developing, and all sorts of crazy things happen. I always find the bear is very frustrating at the end. One plug, Gradle. We love it. I'm not going to talk too much about it, but things like Gradle can really make your life a lot better. And I would recommend, if you're not using it, look into it. A lot of microservices talks always talk about the Lego blocks and how you're building up a component with Lego. I didn't put the Lego in here, but it starts off with edge services. Edge services are the RESTful APIs that you expose to your customers, or maybe to your UI. You want to separate your UI from the core. So once you have your basic container or what you're going to build, then you got to start focusing on how you're going to architect your system. And we architected around edge services first. As you see with the microservices, you want to have separated persistence, and you also want to have some configuration. Everything you build in the cloud should automatically auto-scale. You should always have a load balancer, and you should always have an auto-scaling group. These things are not a lot of work. Once you get the basic principles in place, you can wire it up. It becomes trivial. It becomes so trivial that you just start thinking, hey, if I have 200 instances automatically, it's no big deal. The machines are going to do it for me. Once you get to that level, you start thinking multi-region. And my previous employer, we literally had data centers around the world with tens of thousands of instances. And as a developer, when you write code, you're just thinking, yeah, this code is just going to be deployed all around the world, just running in parallel. Edge services are typically found by DNS. They're APIs that are exposed. You need a security layer in there as well if you're not using public APIs. The recipes that we looked at for this, there are a lot of great solutions out there. If you're an Amazon shop, Amazon has a great API gateway. It's getting more and more powerful. They just enhanced their load balancers. There's a new type of load balancer coming which has great features. We are at GoGo. We're using Hystrix from Netflix and Zuul, which hopefully I'll get to later in the presentation. But basically, you've got to start thinking about edge services and do some research and figure out what components you're going to use. Another key piece of an infrastructure in AWS or any cloud platform is configuration management. You do not want configuration values to be built into your code. Do not do static hard-coded values. You want to load these values in. You need immutable architecture where you can change your servers at any point in time. You do not want an architecture where you literally go into a server, stop it, change a parameter, and restart it. There are a lot of frameworks out there that will do that for you. Zookeeper, Spring Cloud Config, and Netflix Achaos is some examples. And we're using Achaos. With Netflix Achaos, literally is one line of code in Gradle, and then there's a few lines of code, and you can bring in and make all your parameters configurable. And they're configurable in real time. So you can go in and modify parameter in the system, and you can choose to use a database. We use encrypted S3 files. The servers are always looking for change. And these frameworks in Java with a few pieces of code will enable you to write a server that will just pull the configuration from somewhere else. So you've separated the configuration from the code. This is a powerful approach because you will find in some places people panic, we need to change something. They literally have to go into the servers and make these changes, or they have to rebuild the servers. You really don't want to do that. These patterns will also enable the developers to start thinking that, hey, this configuration could change on me while the server's running, because many of us will write code that just load these parameters at runtime, and we think they're static for the duration of the server. With this, it will say, hey, make a callback, enable these parameters to change. Metrics and monitoring. So it's very easy to write code and not know what's happening. Many people think it's a lot of work to instrument your code, but actually it's very trivial to instrument your code. Two examples of great libraries out there, Netflix Server and Yammer Metrics. Several great examples of monitoring tools out there. Graphite with Grafana. Grafana, you need Grafana if you're going to use Graphite. And an elk stack. We did not go with Netflix Server, so I'm not, even though I work for Netflix, I'm not a fanboy and use everything Netflix. We found Yammer Metrics a little bit better for us. It's completely open source. It's in Dropwizard, and there's a few other frameworks. Again, you've got no excuse not to use this. It's literally a few lines of code. You can instrument your product with a few lines of code, you bring in the framework. It gives you great features, meters, gauges, all sorts of great tools. You wire it up. You need a Grafana somewhere, or a Graphite. Once you wire it up, these tools can give you amazing analysis of your software as it runs. we were able to go into servers that had no instrumentation within a matter of days. We were able to wire this up, and we've built some great skills in this area. There are some really cheap hosted solutions out there. Hosted Graphite is one of them, and I think it starts around $50 a month or something. So there are tools out there that will actually host it for you. You just configure your code to send them the metrics. Elkstar is another good one. All right, I said it was doing a marathon. So we're done, right? We've got basic RESTful services, edge, dynamic configuration. We've got metrics. We've got monitoring. So what else could it be? How about some fault tolerance? Fault tolerance is the methodology should be, you should write your code so that you always expect failure. And if it fails, what are you going to do? Again, there are amazing frameworks out there, and one we're using and a lot of people in the industry are using is Netflix Hystrix. Netflix Hystrix was built after we had some major outages at Netflix for very trivial things. Hystrix is basically built to give the developers a framework where when you write your code, you just don't say, you know, this is going to fail, I'm going to give a 500 error. No, you say, hey, if my service fails, I shouldn't penalize someone else. I can have a default. So if you're using a service and say you have user recommendations or something, if that API fails, there's no reason for a degraded experience for the user or a failed experience. So Hystrix enables you or forces you to start thinking about, if this system failed, what would I do? So I'll give you an example for my employer now. In the past, if payments were failing, when a user signs up for internet access, they'd get a cryptic error coming back saying, sorry, payment failed, and the user's pissed off and stuck. Now a system's been developed where we say, you know what, the payment downstream fails, it's not the user's fault. So how about using Hystrix, we'll default to saying that it passed. The user gets internet access, we just don't end up charging them, but they get internet access and they're happy. Meanwhile, in our data, in our NOC, in our operations, our alarms are firing. And we're like, oh my God, we've got to fix this. But the people flying are not unhappy. So Hystrix gives you that methodology where you say, hey, every one of my APIs, I should have a fallback. Because failures always happen, especially in the cloud. Your servers, you're using someone else's infrastructure, and things are going to fail. So you should be building for failure. Hystrix is well documented. There's some great material on the web. I would recommend you go and see it. But this is a good example where one dependency fails. You should not have complete failure because of that. You should have degraded experience, but not a loss of experience. Hystrix has a lot of things in it. Enables you to do load, balance the load. You can do protect the system. And again, it's really easy to wire up. It's a few lines of code. Those few lines of code can enable you to have dashboards where you get extensive statistics about your system. This is all free. You get a dashboard, and every single one of your APIs can be monitored. And you can have a screen with all your APIs in real time to see the health of the system. Here's a piece of the screen that we have now at GoGo. A lot of our key APIs are all showing there. So instead of having thousands of things to watch, we typically have one Hystrix screen, which we're looking at continuously. And that shows you the health. If something goes wrong, and I don't have time to give a demo, but I got a great video of it. If something goes wrong, the green goes red. If something goes wrong, of course, people aren't just sitting there looking at the screen all day. We actually have alarms firing. But you can quickly identify what happens. So by adding a few lines of code and bringing in Netflix Hystrix into your APIs, you'll end up with a whole bunch of functionality and fallbacks that you never had before. And you don't have to reinvent the wheel. And it really is a few lines of code. A few annotations, a few pieces of code, maybe a couple of extra classes, and you're wired up. There's also some reactive in there. There's some RX Java. So there's some really good practices being formed. I don't know if you have the info commercials here. In the US, we have a British guy with a bow tie. But wait, there's more. So there's more. Hystrix, combined with Yammer metrics, gives you incredible statistics about your system. So instead of you actually going in and coding up your system to Yammer metrics and saying, hey, you know, API is this, delay is this, average is this, counters is this, you wire this code up, and for free, with literally a few extra lines of code, you're going to get 30 statistics for every single API. There's a blog post that gives details on this. It's a really good post. But basically, You then can have even more dashboards of your code. You can know the health, the 50th percentile, the 95th percentile, all the key statistics for an API. And then you can have a dashboard just for one API. This one API, then you can look at the health over time. Because quite often you'll find that APIs, as you push out code, you may pass the test, but your APIs may be getting slower. When you look at 24 hours, you may not know what's going on, but when you look at 7 days or a month, then you can get some really good insight into what's going on. And again, all of this is so easy to use. It's a few days learning curve, a couple of open source frameworks. You can bring it into your code base and just get moving with it. Okay, so we're done. So, no. Core services. So, you know, we talk about microservices, but you've got the edge, the publicly facing APIs, and then we have the core. We have the internal APIs. Those internal APIs, you don't want to have a load balancer, and you don't want to necessarily use DNS. So there are a lot of approaches out there. Console is a good one. And then there's Netflix Eureka. Again, these are all open source frameworks. You wire up your code. Netflix Eureka enables your internal services to discover each other. And then you can do auto-scaling groups without having to have a load balancer. So it's software load balancing, basically. An application registers itself, tells it to the Eureka server. A Eureka client, when it wants to find a service, says, hey, where do I get this service? And it comes back with an IP address, and it tells you what server to go to. It's also a really cool feature because as a developer, when you're building code and test, you can actually register your server into the system and become part of the group. So you can actually have live traffic on your personal laptop as well through this. Eureka for us is a critical piece of the system and is owned by DevOps. The DevOps team maintain Eureka, development teams use it as part of our platform. It also enables canary pushes. I'm not sure I'm going to have time to talk about that, but the canary pushes is another exciting area where we are able to push out a single instance into production and route specific traffic to it. Again, how do we wire this up? Here we go, even more open source frameworks. So we got Netflix Ribbon. Netflix Ribbon enables you to do this easily in code. Again, it's another well-supported library framework. It wires up into Eureka. It also wires up into Zuul, which I don't think I got to yet. Great tech blog, postings and information. I think it's also in Spring Boot Cloud as well. Okay, bit of a marathon here. So we're done, right? No. You know, I showed that diagram earlier with all these different people doing all these different roles, and that's why it slowed us down. In this new world, my developers click to production when they decide to click to production. No one tells them to do it. They hit the button, and the code's in production within 5 minutes. If you're responsible for clicking that button, you need the tooling to enable you to have that responsibility. So another part of the organizational change that we implemented was goodbye quality assurance and hello quality engineering. So our quality engineers are coders, they're developers, they write code. They're embedded with the teams. They're writing code with the teams. Because the developers now, knowing that you click the button and you're responsible to push the code into production, you kind of want to have better tests because you have that responsibility. The developers and the quality engineers work together on the same code base and the same tooling. You want to know within minutes if something breaks. When something breaks within minutes, then you've got Netflix Spinnaker. You just log into Spinnaker, you click a button. When you push new code, it's immutable architecture, so you're pushing out new instances. You build from fresh, clean instances. They're sitting there. Your old instances are still there. We're just not sending any traffic. And we keep them for an hour, or what the remaining of the hour billing cycle is for Amazon. If anything goes wrong within the first hour, you just click a button, and those servers are just live, and you go straight back. So you have instant rollback practically. After that hour, we'd have to rebuild the previous version, but that only takes minutes as well. So the pipeline through Spinnaker and the tooling that we built can unit test your code and then can do functional tests. We've been doing some really cool things, and we found some great ways to go forward. So we're using REST Assured as a Java DSL for REST API testing. And in the past, quality engineers would write this code, but it would just sit there and only they would use it. Now we're wiring it up into the production systems. And we've been able to pull all these things together and do some cool stuff. So again, I don't have time to show the videos, but the problem is how do you maintain and monitor your system better? It can't just be alarms and alerts. So we've taken all these core functional tests or integrational tests, and we're running them 24/7 against the code. And then we took some of the frameworks we're using and said, well, why wouldn't we use the same frameworks for the test cases? So we've put Yammer metrics into our test cases because we decided that a test doesn't just pass or fail. It's how well did it pass? How fast was it? These are critical things that we need, and we'll alarm if a test takes longer. When I arrived, we actually had an outage one day because credit cards were taking over 20 seconds to pass. The test cases running in the system were just checking if the credit card API worked, and it was working. It just took 20 seconds. Those of you working in blocking architectures know that a 20-second delay with thousands of users results in a lot of threads, and the system imploded. So knowing that, we've worked on wiring it all up, and I do have a video here, so I'm just going to go straight to that. Let's see if I can figure out how to play it. Oh. All right, the video does not seem to want to play. All right, trust me, the video is awesome. What the video is showing is how this is a Graphite dashboard, and what is really cool is the drop-downs along the top, again, with very minimum amount of work, those drop-downs show you, and you can go into any server in your system and find its test case and see its historical results. We're loving this. We've only been building this for like the last 6 weeks, and we're finding it to be a really powerful feature. So when a test fails in production, we quickly know what test failed, then we can go to these dashboards and look at it. So it's just making us faster, because not only we know we're going to break things, but when we break things, we want to fix them as fast as possible. And you don't want to be running around with teams doing this because no one knows what happened. I've got to figure out how to make this video work. Another quick one for you guys, Swagger. You got to document your APIs, put it in your code. You can auto-generate documents. There's some great commercial products out there. README.io is one of them. Gemalto is another one. Again, it's a few dollars a month. Why build your own developer portal when you can use one of these? They both import Swagger files. Okay, this was a marathon presentation here, but I'm doing pretty good. So to wrap up, there is a lot of amazing code out there. You know, obviously, I have a little bit of bias from my years at Netflix, but Netflix has really put a lot of effort into open sourcing things. But there's more than Netflix. You need to be aware of these tools. You gotta use them and contribute to them. They're going to make your life a lot easier. When a system has hundreds or tens of millions of users and they're using this code to keep that system running, it's ridiculous for you to think, hey, I'm just going to do something myself and reinvent the wheel. DevOps, microservices, all these things are not individual silos. You have to bring them all together and use these types of frameworks. You need systems like Amazon to wire it all up to be successful. Okay, but wait, there's more. I got another one. There's another amazing framework that I'm a big fan of, Netflix Zuul. It's an edge service application. It gives you all these features. You could read it already. I'm not going to read it out to you. But what Netflix Zuul enables is every API coming into the system can be checked and filtered by Groovy scripts. Well, not really Groovy scripts, by Groovy or language of your choice. But it gives you some really powerful things. It's kind of like a load balancer on steroids. And one of the things, and there's a great video, reInvent. If you get the chance to go to Amazon conference, go. But if you can't, the videos are amazing, and go through them. There's some really great videos. One of them, a former colleague, is presenting Zuul. And they literally demonstrated that they could take traffic from a single user out of 60 million, and with a couple of scripts, and a click of a button, within seconds, they're getting that one user's traffic. Imagine that, you know. Zuul also enables you to do things like you can have a production system, and you could put a canary up for one of your services, and you could set it and set some rules that only your test machine gets routed to your canary. So imagine the power of that. And imagine the power, instead of having to build an entire staging environment or development environment, you could actually filter some traffic in production to one instance that you're running. And that could be an instance on your local disk. There's some pretty powerful things you can do that. And again, imagine as a developer the power that gives you, how fast you can develop if you can get that traffic right away, if you don't have to go through all these stages of getting a test stack set up with different people's code. So this is my next mission for the GoGo team, is like, we're going to wire this up and start doing this as well. So anyway, I think my team and I, we've come a long way in 18 months, but as you know, in this industry, things continuously change. We've come a long way, but it's a lot more than just code. It's not about just being great developers. It's about having a great environment. It's about having a culture that accepts that environment. It's investment in tooling. We've invested heavily into DevOps. That is a really costly thing at first, and it's frustrating for developers as they go through these changes, because they may not be understanding what's expected of them. Quality. Quality shouldn't be over on the side under a different organization. Quality is something we all should take seriously and should be embedded within the team. So I think I more or less did it to time here. The cool thing, I think, for us has been increasing expectations. We started where a world where the developers were living where it could take days, if not weeks, to get their code in production. And now we have developers coming to our DevOps team and complaining that, hey, your automated system is so slow, it's taking 5 minutes for my code to be in production. It's not fast enough. I want it to be faster. So it's wonderful to have that environment where we just want to get better. Just yesterday, I had a developer complain that your Tomcat's not the latest. This is crazy. So we quickly fixed that. So we're really making a lot of progress in empowering the developers to expect more. And one of the guys asks for containers every day, but I'll leave that for another day. So thank you. I sped through that. I actually went through that a lot faster than I expected. So any questions? Oh, silence. Yes. Yes. Yeah. No, we'll make this available. There's a lot of links, a lot of material. And feel free to reach out to me. I'm always happy to share what we've learned. We made mistakes along the way. We've made some decisions that we regret like everyone else, but we'll be happy to share what we've learned so far. So, yeah.
If it makes sense, could you talk about the vertical domains and persistence and how you've organized that in terms of microservices?
Yeah. Microservices are easily talked about, very hard to do. The verticals that we do is kind of like what was the model at Netflix, is that you try to build teams around end-to-end functionality. So a vertical would be customers. Everything about a customer in a vertical. And you try to enable that team to own it end-to-end. If you have customers fragmented in the system in multiple teams and anything breaks, then you have teams all pointing to each other and no one really knows what's going on. So it's not as trivial as that. It's really hard, as you probably know, and why you're asking the question. But we try to enable that. The system I inherited, for example, they had one giant monolithic schema, highly SQL-based, relational-based, customers everywhere. What we're working on now is that the customer is in a separate database, its own schema, separate completely from the rest of the system, and they only can talk to it through APIs. It's very painful and very difficult to undo. So I'm not sure if I gave you much of a helpful answer there, but the reality is that's what we're trying to do. Thanks. Yeah.
So along the same lines, how do you manage versioning, service dependencies, and integration of the services?
That's a good question. We're still working on that, and I don't have a perfect answer for that. We're still working on versioning our APIs. But to be frank, RESTful services are getting a little old right now, and there's next generations of APIs as well. WebSockets, JSON RPC. But our basic fundamental approach right now is just versioning your APIs. The reason I like the canary concept is that by enabling developers to modify or add a new API so easily, as a developer, you're going to be heavily forced to version your code and isolate your new API correctly. So, again, I don't have the perfect answer. It's hard work. So, yeah.
You mentioned that instead of QAs, you have quality engineers.
Yeah.
What does the quality engineer actually do compared to a regular engineer?
A quality engineer is, we call them SDETs, software developer engineer and test. I'm sure there's a better term for it. But I just want to emphasize that quality is not a second-class citizen. Quality is a first-class citizen and is our own responsibility. Quality engineers write code. They don't click buttons. They're not manual testing. There is a room and there is a place for manual testing, but I've taken an organization that was like 80% manual to maybe 20% manual now. The quality engineers are as equal to a regular developer. In fact, sometimes they're better, and they hold the developers accountable. They're there to help the developer. The developer production, you know, you can't spend all day writing tests, but you should be writing tests when you develop your code. But the quality engineer is there to assist you and polish it up and make sure that test code gets all the way into the production testing 24/7. Make sense? Thanks. Anyone else? You're like, no, it's food out there. We want to go. All right, I think we're good. Well, thank you very much. I appreciate your time.